There's a place where the Ozark Mountains begin to stretch out into the plains, where farmers work the land and paved roads give way to gravel. It's down just such a road that brings us to a beautiful park with split rail fences and expansive views. Hi, I'm Jim Viebrock. I've spent the last 30 years going all across the country, photographing, documenting, and now videoing old water mills.
It's a beautiful summer's day. We're here in Crawford County, Missouri, on the banks of Huzzah Creek. This is Dillard Mill. Let's take a look around.
There is a short hike down a gravel path to get to the mill. There are several spots along the way to take amazing photographs. Let's take a look at the mill dam before going inside.
Let's talk about the mill dam here for just a moment. This one is unusual in a lot of different ways. Most of the time when we're looking at a mill pond or a mill dam, you're going to see stacked rock of some kind or maybe a poured concrete full-on dam that's built. This one is interesting because it was literally carved out of solid rock, except for that small little section right there. The interesting thing about that section was it was originally made out of wood. There's an artifact in this mill, a diving helmet, where the owner of this mill used to go down, put this primitive diving helmet on, and go down and service the wooden part of the dam. I can't even imagine how scary that had to have been. At some point, the wooden part of the dam completely failed, and they replaced it with the concrete dam that's here today. This mill operates off of a turbine, but they could have just as easily, particularly in this configuration, used either an overshot or undershot wheel. An overshot wheel is where the water cascades over the top and uses inertia and gravity to keep the wheel turning very smoothly. An undershot wheel or a pitchback wheel uses the water hitting the wheel on the backside and causing the wheel to turn in a reverse motion. Both ways, inertia and gravity work together to make the mill work. Topography ultimately may decide which way the miller chooses to operate their mill. In this case, they had enough fall that they were able to use a penstock and a turbine, which gives you ultimately more horsepower than that of either the overshot or undershot wheel. They have a really neat turbine on display here at Dillard Mill. It's in the parking lot of all places, but I wanted to stop and talk to you about it because we're not going to be able to get this close to the turbine that actually powers the mill. And this one's a little unusual because of its size. Not only is it not very big in diameter, but it's also very narrow this way in comparison to most of the turbines that we've looked at. This works really interestingly in that this whole apparatus sits underneath a hole that's in the concrete floor, and around this is a room. The room is called a penstock. The penstock gathers the water above the turbine. The deeper the water in the penstock, the more horsepower the turbine will have. Now it works by opening this little gate right here. This will have a shaft that goes up into the mill. You open a little wheel and it opens these gates. These gates are called wicket gates. When they're closed, the very little or no water goes through the turbine at all to be discharged. As you open them up, then the turbine comes to life. That force of that weight of that water starts to go through these slots and turns an impeller inside the turbine. Again, the deeper the water, the more horsepower you have. Now, the impeller's attached to this shaft. This shaft goes up into the mill and operates the pulley system. What I think is fascinating about these is modern hydroelectric dams are powered by turbines patterned off of these early turbines. They're very similar, they're just much more modern.
A small group of people have gathered inside the mill. Yvonne Bobbitt, Historic Site Supervisor, is in process of giving a tour. Let's join in.
So basically what would happen, the farmers would take turns by backing their wagons up at those double doors. They would come in, place their grains on the floor scale, and the miller would weigh it out and keep 1/8 of those grains as a payment. After it was all weighed and settled, he would come right over here and he would dump that wheat grain into the sink, this floor sink, that has an auger on the inside of it that'll carry that grain over to these little scoop elevators. That's going to take them on up to the second floor where it goes through a series of cleaning machines. Now, as the wheat has been cleaned, it's going to eventually come back down to this level, and it's going to come down from the clean wheat bin through this metal spout into the top of this roller mill, which they call the first break. That wheat's going to come down into these two pairs of corrugated rolls that are moving at slightly offset speeds, and that will remove the outer husk off, which is called bran. Now, from here, this product, the entire product, will go into the basement, catches another ride by elevator, and goes on up to what they call a bolting screen. And that screen has various gauging of wire, including a fine silk screen. Now, you're going to get flour right off the bat, off this first machine, but you're not going to have all flour. It's going to have larger pieces of the wheat. You're going to have the bran all mixed in it. So everything is separated upstairs at that point. So the larger pieces of wheat will be re-ran into the first roller mill on the backside, and then the bran will be taken over to the bran duster. Now, as the wheat travels through the system, it goes down into the second rolls, which contain smooth rolls. And that's going to further reduce your wheat in size into a little bit smaller. In the meantime, the bran, of course, has been taken over to the bran duster. Of course, this is what it looks like. There's going to be a lot of flour that's going to be stuck to the bran, and they want to try to save as much flour as possible. So the bran will be shipped on the inside of that screen reel. There's a paddle brush on the inside of it that'll push this bran up against the inside walls of the screen. The exterior horsehair brushes, in the meantime, will start to sweep or push any flour through the screen, and it'll eventually drop all the way down to the bottom. If you look at the very bottom, you'll see an auger, and that auger will carry that flour down into the basement to an elevator, and then eventually be transferred over to your flour bin. Of course, this is the flour bin where the bulk of that flour was stored. This is a flour packer. It works on a counterweight system. A barrel could be brought in, placed on the stand. There would have been a weight suspended off of this arm. The miller would push this foot pedal down, that stand rises up, an auger engages at that point and slowly starts to pack flour into the barrel. As it hits that predetermined weight, it lowers back to the floor and you could remove it. On the other hand, you could also sack it up manually by turning this hand crank and of course hanging the sack like this one's displayed.
Dillard Mill is also set up to grind corn. Let's take a look at some of that equipment.
The very first thing that has to happen when the farmer brings the corn to the mill is that they would weigh it. In Dillard Mill here, they have a nice floor scale here. So the first thing they would do is weigh the corn on the cob and agree to the amount they had there. From there, they would be putting perhaps a bushel at a time into a sheller like this. This is one of the nicer corn shellers that I've seen inside the mill. This is a pretty good size one. You'll also find the little hand crank ones. We'll look at one of those here in just a minute. But this one is fully automated. The corn on the cob goes in here. It has to be dry when it goes in here. There's a fan in here that blows the debris and the light stuff off of it. The cob and the heavy stuff will fall out on the shaker. It goes back and forth like this, and the kernels then fall down into the floor where they're elevated to the second floor of this mill to run through a cleaner separator. Now you want that clean, you want your corn kernels to be as clean as possible whenever you send them to the grinder. One of the pieces of equipment here in Dillard Mill is this really neat vertical stone grinder. Now inside this housing here is going to be two stones. One of them is going to be stationary, one of them is going to turn running off of the pulley powered by the water here in the mill. The one that is stationary is called the bed stone. The one that is running is called the running stone. What they do is they work against each other and they grind that corn. There's grooves in there in those stones that the corn kernel drops down in there, and as it rotates against each other, it grinds it down to whatever consistency that you have. Now you adjust it with an adjustment like this, and to get it either finer or more coarse, you move that in or out. Now the corn goes in a hopper here. It drops down into this. This is called a shoe. This vibrates as it's running, and it aligns those kernels up so they can go in the hole in between the stones and grind. Oftentimes you would see the millwright reaching down and grabbing some of the millings out of the grinder. He would then be running them between his thumb and his forefingers like this. This is where the expression, the rule of thumb, comes from. So he would also sometimes be smelling it. And this would be the expression, keep your nose to the grindstone. And what he was smelling for in that was if the stones were too close together, they would have a kind of a burnt smell to them. So you would be seeing him check for both the consistency of the millings as they came out and the smell of the millings as they came out to make sure that the grinder was properly set to grind.
They have a couple of really good millstones outside. Let's go take a look.
One of the things I like to stop and look at when I'm at these mills is the millstones, and they almost always have them laying around the yard somewhere. They've got a handful of these laying around here at Dillard Mill, and I want to show you this one, which they've incorporated into a retaining wall of sorts, but it's still here, and it's still things that we can talk about with it. One of the things that all of them have in common is these grooves right here. Those are cut in there to work the kernels as the stones rotate, to work those kernels down and pulverize them into the powder or the consistency that you're looking for. Now the bed stone is the one that is stationary. The running stone is the one that turns. Both halves of these are going to have those lines, and they have to be recut from time to time, and that's called dressing the stone. Now there's something else about this stone that I want to point out. This stone actually is a modular stone. You can see it's got these different sections to it. And there was a couple of benefits to that. That would have made this stone much easier to move. A running stone or a bed stone can easily weigh 2,000 pounds or more. This one probably altogether would weigh somewhere around 1,500, 1,800 pounds. But the best part about that is because this is modular, you could take it apart and then you could move each individual piece, which makes this much easier to move around. Now these stones are most likely granite, and they most likely came from France. So the stones also had another benefit with the process of bringing them across the ocean, and that is the weight of these stones were put in the bottom of the sailing ships to be ballast. So there's just a lot of really neat things about these stones that I like to point out. In the 1800s and early 1900s, they didn't waste anything. They recycled everything. And this is a good example of that. This is a relatively large silage chopper here in Dillard Mill. Now, it runs off of a flywheel over here. You would put your corn stalks in here. You would put your corn cobs in here. And there's a chopper inside of here that chops it up into real fine bits. You would feed this to your hogs or some of your livestock, different things like that. They wasted nothing. So even the corn cob was reused as feed or for something else.
Now this part of the mill was added on in the 1930s by Lester Clemmy, and this is what he called the feed mixing room. In this 55-gallon drum, he would put molasses, and in this tin hopper, he would put various grains like corn or oat or wheat in there. And eventually, the molasses and the grains would be met together in here. There's a metal auger on the inside that will begin to mix it up. As it's being mixed, eventually it'll be dumped into this wooden box. And if you look on the inside, you'll see these handmade wooden augers that will continually mix the product together and bring it over to the end to where you can sack it up as it comes on through.
Not only did the farmer come to town to get his corn and wheat ground, the whole family would come with him. Dillard Mill actually has old cane poles hanging on the wall so that the farmer would have something to do while his crops were being processed. I think that's brilliant. But the mills were the focal point of the communities in which they served. It just wasn't uncommon for the whole family to come along. They would have picnics by the mill pond, and they would do all kinds of things. Some places even had a general store in close proximity. Dillard, the city of, was no different. There was a small community here, there was a blacksmith here, there was a small school here, and there was a general store here, all in close proximity to the mill. When the mill does good, the community does good. When the mill folds, so does the community.
Dillard Mill is now under the care of the Missouri State Park System and is in very good shape. Let's open the turbine and watch this mill operate. one of these mills has its own personality and its own story to tell. They are unique American treasures. I'm Jim Viebrock. Let's go find another mill to explore.